Hello students. So today we are going to do some extra problems based upon 3D geometry. Now here the question is, find the image of the point 163 on the line. Equation of the line is given in Cartesian form. Also write equation of the line joining given points and its image, and find the length of segment joining given point and its image. Okay, so first we'll draw a rough sketch. Okay, so the point is here. Okay, now this image of the point on the line. So we have a line here. Okay, it's this point's image will be here, right? So we have to find point, that is its image, and then you have to find the length of the segment joining given point. So length of the segment joining given point and its image. So from here to here we have to find the length. Okay, let's denote this point as P. Then this is Q. This line is our AB line and its image be T. Okay, so first you have to make use of the information which is given. Now here the equation of the line is given. Okay, so this line is our AB line, so we can write that equation of AB, that is x upon 1, y minus 1 upon 2 and z minus 2 upon 3. Okay, so from this we can find the direction ratios, right? So we can write this as equal to lambda, and also we can find this direction ratios will be 1, 2 and 3, right? Also we can find the point, this point, Q point. Okay, because this Q point is on the line AB. Okay, so we can write Q point using this equation. Okay, so substituting it is equal to some lambda. Okay, we'll get x equal to 1 lambda, y equal to 2 lambda plus 1 and z equal to 3 lambda plus 2. Okay, so this is our point x, y and z. So this point is on the line AB, which is our point Q. Okay, so Q point is lambda, 2 lambda plus 1 and 3 lambda plus 2. Okay, now we know that, now if you look at this point is 163 and this point is our lambda, 2 lambda plus 1 and 3 lambda plus 1. Okay, so the direction ratios of the line PQ, direction ratios of PQ will be what? How we write direction ratios of a if 2 points are given, direction ratios are given by x2 minus x1, y2 minus y1 and z2 minus z1, right? So direction ratios of PQ is lambda minus 1, then 2 lambda plus 1 minus 6, 3 lambda plus 2 minus 3. Okay, so this is lambda minus 1, 2 lambda minus 5, 3 lambda minus 1. Okay, these are the direction ratios of PQ. Now this PQ is perpendicular to AB. Okay, PQ is perpendicular to AB and we know the direction ratios of PQ and also the direction ratios of AB. Okay, so we can make use of the perpendicular condition, that is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Okay, so our A1 is from AB, so it is 1. These are the direction ratios of AB. Okay, so 1 into lambda minus 1, so lambda minus 1 plus 2 into 2 lambda minus 5 plus 3 into 3 lambda minus 1 equal to 0. Okay, so this will be lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 equal to 0. So we can find out lambda from this. So lambda, 5 lambda plus 9, so it is 14 lambda minus 4 minus, so this is also 14, so our lambda is 1. Okay, so now we can find the point Q substituting lambda. So 1 2 plus 1 3 into 1 3 plus 2 5. So our Q point is 1 3 and 5. Okay, now this Q is the midpoint of PT. Okay, this is the midpoint of PT, line PT. Okay, now we can find T by using midpoint formula, because we know point P and also point Q. So what does midpoint formula says? Midpoint formula, now we are finding this Q point is our midpoint, right? So x1 plus x2 upon 2, y1 plus y2 upon 2. So our x1 here 3 points are there. Okay, z1 plus z2 upon 2. So this is 1 plus x2 upon 2, then 6 plus y2 upon 2 and 3 plus z2 upon 2. Okay, comparing with the points of Q, so this is our 1 plus x2 upon 2 equal to 1, so we'll get x2 equal to 2 minus 1, so 1. Okay, then 6 plus y2 upon 2 equal to 3, so we'll get y2 equal to 6 minus 6 0, and 3 plus z2 upon 2 equal to 5, so we'll get z2 equal to 10 minus 3, which is 7. So our point T is 1, 0, 7. Okay, this is the image. Now this is the image of the point P, and now you have to find the length of the segment from P to T. So you can use distance formula. Okay, so using distance formula, length of PT root of x2 minus x1 1 minus 1 0 square plus 0 minus 6 6 square plus 7 minus 3 4 square. Okay, so we'll get root of 36 plus 16 52. So this is root of 52 units. This is the length. Okay, so this is the question. Let's solve another question. Okay, so you have to find the length and foot of the perpendicular drawn from the point to the line. So this is exactly same as the previous question. Only thing is here you have to find the that perpendicular point and the length. Okay, so drawing it will be like this. Okay, this point is given 2, -1, 5, and this line is given. Okay, say AB. So AB line is this, the equation which is given. Okay. So first thing you have to find is this point. Okay, using the line. So our equation of line is equation of AB x minus 11 upon 10 y plus 2. I'll write this in the general form, that is y minus y1, like that. So this will be minus of minus 2 upon minus 4 equal to z minus minus 8 upon minus 11. So this thing you have to equate it to some lambda. Okay, so that you will get this point, that is point O. So your x point is 10 lambda plus 11 y minus 4 lambda minus 2 z equal to minus 11 lambda minus 8. Okay, so this point is your xyz, that is 10 lambda plus 11, then minus 4 lambda minus 2, and minus 11 lambda minus 8. Okay, now you have to find the direction ratios of line PO. So direction ratios of PO. Direction ratios are given by x2 minus x1, y2 minus y1, and z2 minus z1, right? So this will be 10 lambda plus 11 minus 2 minus 4 lambda minus 2 minus plus 1, then minus 11 lambda minus 8 minus 5. Okay, so this is 10 lambda minus plus 9 minus 4 lambda minus 1 minus 11 lambda minus 30. Okay, these are the direction ratios of PO. Now we also need direction ratios of AB. So these are the direction ratios of AB. Since it is given perpendicular, we can make use of the equation A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So multiplying the direction ratios, you will get 10 into 10 lambda plus 11 plus minus 4 into minus 4 lambda minus 11 minus 1, then minus 11 into minus 11 lambda minus 13 equal to 0. Okay, so this is 100 lambda minus into minus plus 4 plus 121 lambda 13 into 11 143. So this is plus the 0. Okay, so all lambdas you have to add, so you'll get 100 plus 121, so 221 plus 16 237. Then 110 plus 143 plus 4, 257. Let's recheck if I've made any mistake. Oh, I've not taken this. This is 9. So this is 90. So adding 90 plus 143 plus 4, 237. Okay, so again lambda comes to 1. So substituting lambda in our point O, we'll get 10 plus 11, so 21, sorry. Then here it will be minus 4, minus 2, so minus 6. Then minus 11, minus 8, so minus 19. Lambda is minus 1, sorry. Minus 10 plus 11, minus plus, so 4 minus 2, and 11 minus 8, so you'll get minus 1 plus 1, 2 and 3. So our point is 1, 2 and 3. Now you have to find the length. Okay, length of PO. Using distance formula, we'll get 1 minus 2, 1 square, 2 plus 1, so 3 square, and 3 minus 5, so 2 square. 1 plus 9 plus 4, root 14 units. Okay.